Hello everyone, my name is Ayush Goel. Welcome to GradeUp. Right? Now we are starting with the next subject, compiler design. Okay? I hope you are clear with the subject theory of computation. Now we'll be moving to the next part of TOC, you can say that, compiler design. If you are clear with the TOC subject, you will be very comfortable in this compiler design subject. Right? As I said, most of the things are common. Like you studied grammars, same grammars we are going to use in our compiler. You studied ambiguity, we'll use that concept in our compiler. Okay, so all the things are related. So I suggest you to first complete TOC if you haven't done, then come to this subject, compiler design. Right? This subject is very easy I am saying. Okay, near about it comes for 5 to 6 marks in your GATE exam, and those marks are really easy to fetch. Right? If you study properly this subject, 5 to 6 marks will be a very game to you. Okay, so please focus on this subject very well and finish this as soon as possible. This is not a very big subject, this is a very small subject, very small. Okay, so study it, practice it and finish it, keep it aside. Okay, so let us begin with compiler design. Right, now forget everything which we have done before. Now come on to a new beginning, compiler design. But remember the concepts of TOC, don't forget everything. Okay, remember the concepts of TOC, that will be very helpful in your compiler design subject. Right, let us start. First, we'll see the GATE CSC weightage. Okay, what are the weightage for compiler design in previous year? See, in recent 2018, it came for 6 marks. In 2017, 2 sets 4 and 4. In 2016, 2 sets 5 and 5. Okay, 2015, 5, 4 and 3, 6, 7 and 5. Right? So these are the previous year analysis. If you take an average, what will be average? Approximately 5 to 7 marks. Approximately 5 to 7 marks, it comes every time. Okay, even in your ISRO exam, right, NILIT exam and more PSU's exam, this subject is asked everywhere, and not that much difficult questions are not asked. Okay, very simple and basic questions are asked from compiler. Right, there are not that much options available as in other subjects. Okay, very limited topics are there, hardly 4 to 5 topics you have to study in compiler. Okay, so finish this subject as soon as possible, that will not take that much time. Right, and practice limited questions, give test series and furnish your subject. Right, so let us begin with compiler design. What is the best book to refer? You can refer Ullman, Jeffrey D. Ullman. Okay, this is a nice book, but you don't need a book for compiler. Everything you will get in these videos and from other sources, right? As I said, refer to standard book only when you have some doubt. Same thing I have told you in previous subjects also. Don't try to study the whole standard book. It contains those topics also which are not required, right? So if you have any doubt after watching the video or after studying from anywhere else, then refer your textbook. Okay? So the textbook is Ullman. You can practice questions from it. It contains good questions and questions are also asked from this in your GATE exam. Right? So better practice problems for it. Okay? Now let us begin with your compiler. Now let us begin. See, now you know what is the weightage analysis. You know what is the best book. Okay? So now let us begin. In this video, we'll see the basic of compiler. Introduction. What is a compiler? Right? See here. See. This subject basically deals how your instruction is being executed or compiled. There are 2 steps, compilation and execution. There are 2 steps. Suppose your code, you have run your C code, right? First you compile it. And then you execute it. So our motive is this one. How your code is compiled. See here, see this diagram. You type your code, you type your instruction high level language, or you can say human language, in simple English or an algorithm language, right? Hash include or cout, printf, right? These are high level languages. The computer don't understand all these things. What does a computer understand? Machine language or a low level language, binary format, right? So you type your code in high level language, then what are the processing done on that high level language? See, the first step is a preprocessor. Preprocessor converts your high level language into pure high level language. What is meant by pure high level language? Suppose you have used some shortcuts. You have used some shortcuts in your code. Then that shortcuts will be replaced by the original code by preprocessor. Okay. We'll study detail in preprocessor in our next slide. Just wait up till here. Just know what does the preprocessor do. Preprocessor replace the shortcuts used in code by the actual code. Right? Now you got a pure high level language. Now, what will a compiler get? Pure high level language. What will be the output? Low level language. What is the output? Low level language. You can also say assembly language. You can also say machine language. Both, these are same. Right? Just different names. So I'll say low level language. Right? I'm repeating once more. You give your instruction in high level language. That will be given to preprocessor. Preprocessor produces pure high level language. This pure high level language goes into compiler. Compiler produces low level language. This low level language goes into assembler. What does an assembler do? Assembler produces a relocatable machine code. Okay? Assembler produces basically a relocatable machine code. Relocatable means which can be relocated or which can be placed in the memory. Okay? Relocatable machine code. Now this relocatable machine code goes into a linker. Linker. What does a linker means? Which produces a single relocatable machine code. Suppose your program is in different sections. Your program or your instruction is in different sections. But linker will combine all those sections and produce a single relocatable machine code. Got it? Now it will go into loader and loader loads that machine code into the memory. And now it is ready to be executed. Now it is ready to be executed. So this is the basic flow of a compiler, you can say, of a compilation process, right? First, high level language goes into preprocessor, then pure high level language is produced. It goes into compiler, which produces low level language. It goes to assembler, which produces relocatable machine code. Then it goes to linker, single relocatable, then finally into loader, and your program is in memory to be executed. Right? So this is the basic flow. This is the basic flow. Our main concentration in this subject, our main concentration will be on this phase. Compiler. Okay, our main concentration will be on this. If you pick that book, Ullman, you will find everything. Preprocessor also, assembler also, linker also, loader also. But that is not required for GATE or for other PSU exams. Okay, only thing required is compiler. Right? So we'll focus more on compiler. Right? As I said, we'll discuss preprocessor. It is somewhere needed in your GATE exam. That's why I'm discussing. See, as I said, it replaces shortcuts used by the user by the actual code. It replaces the shortcuts used. Then what are the shortcuts? See here. See here. Hash defines square x. This is a shortcut. This is a shortcut. See, hash defines square x. I have defined a square x as x star x. Okay. So wherever square x, see here, square x, this is a shortcut. This is a shortcut. And what is the full thing of this shortcut? X star x. See, what is the meaning of square x? X star x. Okay. So what does a preprocessor do? Preprocessor replaces this shortcut by the actual code x star x. Suppose, now this question actually come into a previous year GATE exam. You can find it yourself, right? See here what does do. Int x equals to 4. Okay, you know how to execute a program. Now you know int x equals to 4 and a variable y. Y equals to 64 upon my square x. 64 by square x. Now if you don't replace, what will be the answer? Square x. What is square x? Square of 4. So you think square of 4 is called? What is square of 4? 4 into 4. That is 16. Now you will do 64 by 16. Answer is 4. You will mark answer as 4 in your exam. You will mark answer as 4. But that is not the way. The first process of compilation is preprocessor. Preprocessor replaces. How it will replace? It will replace 64 by, what is square x? Square x is x into x. It will replace like this. Now what is x? 4. So 4 into 4. Now how this will be executed? Divide and star both have same precedence, right? But associativity is from left to right, right? So now first 64 by 4 will be executed. What is the answer? 16. Now into 4. What is 16 into 4? 64 will be printed. See, 64 will be printed. And if you not replace, 4 will be printed. So that will be the difference. So please keep this thing in mind. Preprocessor replaces the shortcuts used. Got it? Answer will be 64, not 4. Cleared? That is the main motive of preprocessor. Right? So now see the topics we are going to study. Very small things. Only 6 topics are there which you have to study. First thing will be phases in compiler. There are 6 phases in compiler. Okay, we'll see them one by one. Lexical analysis we'll see. Parsing. There are 2 types of parsers. Top-down parser, bottom-up parsers. Then syntax-directed translation, intermediate code generation, and runtime environment. These topics, very small topics you have to study. Now, if I tell you the weightage, 5% phases of compiler. Okay, 5% or you can say 10% lexical analysis, 10% lexical analysis, 80% is parsing. Seriously, 80% is parsing. We'll discuss majority time parsing in our videos. Okay, 80% is parsing and the remaining, you can say 7% is syntax directed translation, and the remaining things. I have exceeded your limit. Does I have exceeded? You can take. Don't forget about 7%. Rest are the things about SGT, intermediate code generation, runtime environment. Basically, if I summarize, the majority topic is parsers only. The majority topic is parsers only. Right? So that are the topics we are going to study in our compiler design. Okay. So this was about our introduction on compiler design. Now we'll be starting with this subject. Okay. Our next video will be on phases of compiler. What are the basic phases of compiler and how do that work? Okay. So practice simultaneously. Try to maintain or make some short notes from the videos. Right. So that when you revise this subject, it will be very easier. Okay. So stay updated. Thank you so much.